I'm Wolf McNally, lead researcher for Blockchain Commons. In this video, I'm going to provide an overview of Gordian Envelope, our technology for structured yet flexible and privacy-supporting smart documents. Blockchain Commons is a not-for-profit social benefit corporation that advocates for the creation of open, interoperable, secure, and compassionate digital infrastructure. Our goal is to enable people to control their own digital destiny and maintain their human dignity online. Blockchain Commons is doing this by building a stack of technologies that can be easily adopted by developers. We invent new solutions where needed, but also integrate existing best-of-breed solutions where they already exist. In a previous video, I described in detail our reasons for selecting one such existing standard, cbor, as the solution for our frequent need to serialize structured binary data. In this video, I'm going to discuss Gordian Envelope, which is based on a cbor foundation but addresses significantly higher-level problems. We chose to call our solution envelope because it's a good metaphor for what we're trying to accomplish. When thinking about the humble envelope, the first thing many people think of is a container for documents. You put something inside an envelope. The contents of an envelope might be readable to anyone with access to it, but they might also be encrypted in some way and only readable by people who have a specific key, or they could be redacted with some information made entirely unavailable. Envelopes can hold simple messages, but they can also hold credentials signed by third parties that authenticate or authorize the credential's subject in various ways. The amount of data contained in an envelope might be small, or it might be very large. But aside from the sort of documents that envelopes contain, we shouldn't forget that envelopes themselves are documents. Even without knowing the contents of an envelope, its exterior can be marked with all sorts of useful information describing how it was sent, who it's intended for, and much more. The outside of envelopes can even hold signatures or seals that authenticate the sender. When we think of envelopes, we might also think of privacy, and envelopes are often designed to make the contents hard to see, or sometimes reveal part of the contents without revealing the whole thing, or have other security measures to protect valuable content. Since envelopes are both containers and documents, envelopes can contain other envelopes. And as we're ultimately designing a data structure here, there's really no theoretical limit on how deeply envelopes can be nested. Finally, all the features I just described can be mixed and matched, tailored to the needs of particular applications, whether very specialized or highly innovative. Using this envelope metaphor, which recognizes that envelopes are both containers for documents as well as documents themselves, Blockchain Commons set out to create a container format for smart documents. We had two major goals in mind. First, we wanted our format to be structure-ready. A document at its most abstract is information about a subject, and both the subject and the information about the subject can be complex. So what we needed was a meta-document that could contain or refer to other documents. Envelope's basic structure is a tree, but because every node in the tree is itself an envelope, this means that it can represent a variety of graphs, including node label graphs such as JSON-LD and RDF, edge label graphs such as Neo4j, and graphs that support both node and edge labeling simultaneously such as RDF star and most NoSQLs, as well as simpler graphs such as linear lists. Envelopes can also refer to other envelopes using digests or other identifiers, creating distributed knowledge graphs. Our other goal is to be privacy-ready. Gordian Envelope protects data privacy by supporting progressive trust, allowing for holders to minimally disclose information using elision, encryption, or both without invalidating signatures on the document, and then to optionally increase that disclosure over time, again without invalidating signatures. The fact that a holder can control data revelation, not just an issuer, creates a new level of privacy for all stakeholders. Blockchain Commons made two major architectural decisions to support these goals. First, envelopes are Merkle trees, with each node carrying a digest computed from all its child nodes. Second, envelopes are deterministically encoded, which means that two envelopes built with exactly the same information will necessarily result in the exact same envelope, regardless of the order in which its components are assembled, and that two envelopes with the same top-level digests must necessarily refer to the exact same information in their unencrypted and unelided forms. So what is the easiest way to understand the structure of Gordian envelope? The simplest way to think of it is as a structure with a subject and a list of assertions about that subject. As you can see, the subject is itself an envelope, so it's a recursive structure. Each assertion is a pair comprising a predicate and an object, each of which is itself an envelope. This makes it very easy to express semantic triples like Alice knows Bob. In the example you see here, the subject, predicate, and object are all cbor UTF-8 strings, but they could be any deterministically encoded cbor object. An envelope can also be a bare subject with no assertions, or a bare assertion with no subject. The fact that every element of an envelope is itself an envelope lets us be as semantically expressive as we wish. Here, we started with our simple Alice knows Bob envelope and added an additional assertion to every element. We added a second assertion to the subject Alice. We added an assertion to the predicate knows, and we added an assertion to the object Bob, and even added an assertion to the knows Bob assertion as a whole. This ability to have assertions with assertions lets us, for example, add structured metadata to any part of an envelope. In this example, each has-name assertion for the described literary work carries its own assertion that declares its language. Finally, here is a preview of some of the envelope-related resource Blockchain Commons has available for you to explore. All of the links for these are in the video description. For more on Gordian envelopes here on YouTube, please see our entire envelope playlist, including our video overview of the envelope CLI that allows you to experiment with the creation of actual envelopes. If you prefer text, take a look at our envelope overview article. You can also read our envelope CLI tool docs, and even take a look at our foundational specification docs. We've also put together a large set of use cases that demonstrate real-world uses and advantages of the Gordian envelope data format. We're excited about the new possibilities that Gordian envelope opens up, and we thank you for coming on this tour with us. We're looking forward to hearing your questions and ideas.